So far we've looked at momentum problems in one dimension. Today we're going to look at problems involving collisions in two dimensions. Here's our sample problem. We've got a 5 kilogram ball that is travelling in the x direction with an initial velocity of 6 meters per second. It strikes a 3 kilogram ball, which is initially at rest. After the collision, the 3 kilogram ball travels at an angle of 60 degrees from the x-axis, and the 5 kilogram ball travels at 30 degrees below the x-axis. Determine the final velocities of both balls after the collision. So to help make sense of this problem, we need to do a sketch. So the 5 kilogram ball is initially travelling at 6 meters per second. The 3 kilogram ball is initially at rest. After the collision, the 3 kilogram ball moves off in a direction that is 60 degrees to the horizontal or to the x-axis. So its final velocity we need to work out. And after the collision, the 5 kilogram ball travels at an angle of 30 degrees below the x-axis. So its final velocity is unknown. And I made a boo-boo here. This should be the final velocity of B. Now these final velocities have both x and y components. We have here the x component of velocity B and the y component. And in this, the 5 kilogram ball, we have the x component of its velocity and the y component. So when momentum is conserved in two dimensions, it means that the total momentum before collision is equal to the total momentum after collision in both the horizontal and vertical directions. In short form, we can say that the momentum before in the x direction is equal to the momentum after in the x direction, and that the momentum before in the y direction equals the momentum after in the y direction. So let's look at momentum before and after in the x direction. Firstly, we'll expand this equation out. Now we can simplify this because the initial velocity of the 3 kilogram ball was 0, so that makes that 0. Okay, so we're going to look at the final velocity of A in the x direction and final velocity of B in the x direction. So using trig, we can say that the final velocity in x-axis is given by VA cos theta. And for the velocity of B in the x direction, we can say that it's the velocity of B cos theta. I should put B, the angle we're talking about for each of these. So theta B is this one. So we can write this into this equation. So this now becomes so we can now substitute in some of our known values. So the mass of A times the initial velocity of A in the x-axis was 6 meters per second. And this gives, so I'm just going to rearrange this, and I'm going to call it equation 1. Let's now look at momentum before and after in the y direction. We'll follow a similar process. I'll expand this equation out. Now, since the 3 kilogram ball was stationary initially, we know that's 0. And don't forget, the 5 kilogram ball, its initial velocity was only in the x direction, so therefore there was no y component, so this also goes to 0. So again, using trig, we can say that the final velocity in the y direction is given by, and the final velocity of object B in the y direction is given by. This means we can rewrite this equation as so. So now we'll substitute our values. This gives, and I'm just going to put this on the other side. And then I'm going to divide both sides by this value here. And this will give me, and this becomes my second equation that I'm going to use. I'm going to substitute this into the first equation. So firstly, I'm going to substitute this value for VB into this equation, and then I can rearrange and solve for the final velocity of A. And then once I have the final velocity of A, I'm going to substitute that back into this equation to find VB. So as I said, I'm going to substitute 2 into 1. This gives me, and then I'm going to combine these like terms and then rearrange and solve. So that means the final velocity of the first ball is 5.196 meters per second at an angle of 30 degrees below the x-axis. And now I can substitute this into our second equation. And it gives an approximation of 5 meters per second. So this means the velocity the final velocity of the 3 kilogram ball is roughly 5 meters per second at an angle of 60 degrees from the above the x-axis. And that's it.